It's really nice to see a lot of people in the Miami tech environment. This is the first time that I attend one of these events in a long time, so I'm very glad to see it. All right, welcome. Before we start the talk, I wanted to just mention we're going to go really fast. There's a lot of stuff to cover, please pay attention because you might miss something really important if you just squint for like a couple of seconds. Okay, so. Let's go. I moved here when I was about 18 years old and moved to different places, studied in different places, worked in different places, and eventually I ended up founding Kmeleon, which is a consulting group that focuses around AI, specifically generative AI. We give services all the way from ambitioning and design to development and adoption and change management even. We are pretty deep into the AI world. We even publish stuff. We're pretty geeky about it. So what should we pay attention to this talk? Why is it important to be here? All right, let's go quickly. Why? Because learning is fun, right? We all love to learn. But besides that, because out of this talk, hopefully you're gonna get some ideas of how to make your customer experiences better, and you're gonna save some money on your AI services. I know some of you are paying a lot of money for that, and also hopefully you're going to get better performance, and time to market is going to be smaller for you guys. And finally, this is all going to be within a framework of compliance and IP protection. All right. So anyway, what are the main purposes or the main use cases for fine tuning? Here are some of them. One of them is reducing the prompt length, which is going to save you some money, and it's also going to save you some time during the creation of the application, and also teaching new skills. I think there was a little bit of context around that, but yes, it's true. You can add some new skills to your model and teach it to do something that you specifically want. Improving the tool use as well. Oh, sorry. Oh, my bad. Improving the tool use. Maybe you have some tools specifically, some connections specifically for your application that you want your LLM to learn. And also, maybe you're working on a specific domain where you need the LLM to understand certain things. So those are general purpose cases. But then there are some specific vertical cases. Maybe you want the LLM to interpret something that you're saying and translate this to code. Or you want a specific dialect of a translation of a language to be done in a particular way, so you can teach the LLM to do that without having to prompt the whole thing, right? And then also style and formatting. Maybe you want the LLM, and tonight we're going to give you an example of how to do that, how to style the responses of an LLM to make it more specific and save yourself a bunch of time and trouble. And also maybe you want to infuse some specific customer information. That's going to be quite important for some areas, such as finance or marketing and things like that. So, what does it mean to fine-tune LLM? The previous speaker helped me here a little bit, but maybe some of you know already. Anyone knows what does it mean to do that? Okay, what does it actually mean? It means to basically take some information, add it to the base model, and then come up with a new model that is going to help you do new things, right? Let's just call this a simple version, right? We're going to go into a more complicated version, but let's just call it this way for now. So, in the Gen AI spectrum of where fine-tuning falls, basically is somewhere a little bit more advanced than a RAG technique, and less work and less effort than actually training your own model, as you can see here. So, of course, on the left side is prompt engineering, and I think most of you probably are familiar with that. And so, how does everything look together? So, if you think about an input of a user, and then usually you have some prompt engineering in front of your application, to sort of help or guide the model into something in particular, like tone or style, or maybe some sort of intent mapping and things like that. And then you might have a rack where you augment some dynamic information that you want your LM to be familiar with. And then is the fine-tune model, where you could fine-tune model so that you don't have to really prompt a lot of stuff so that you can get the right response. And also, you can improve accuracy and improve how the model handles the data that comes from the rack and things like that. And then finally, you get your output, your answer, okay? So let's go into the fun stuff. So how to fine-tune an LLM. So this is the Enterprise Edition, detailed version. And so first of all, we need to define business and compliance requirements, right? So you need to define why is it that you want to fine-tune the model, how much money you have, what is it that you're going to do with it, why are you doing this, right? Basically, it's the why. And then second, then you need to select the base model for your fine-tune. And also you need to select the right approach. There are different approaches for fine-tuning, so you need to do that. There are many models out there. We're going to talk about that. And then, of course, you need to select the data that you're going to use. And then, of course, process it. That's the hardest part usually, but you need to do that to get some good results. And then, of course, it comes to setting up your own environment, your test environment, dev environment, whatever you need to do, the tools needed. And then, of course, fine-tune the model. And then once you fine-tune the model, you need to test it and evaluate it through different statistical methods. Anyone here has done fine-tuning model before? Just to a raise of hands. Okay, a few people? Great, perfect, nice. So, and then, of course, after that, you need to deploy the model and make it available for your developers. Maybe you're a data scientist. You created this model, fine-tuned it, and then you want to ship it out there. You need to make it available. And then, of course, there needs to be some sort of, if this is enterprise ready, there needs to be some sort of compliance and documentation review for it. Otherwise, you might get fired or you might get sued. So you better be careful with that. And then, of course, you need to iterate and improve. This is really a process. If somebody here is a data scientist, anyone here is a data scientist? Okay, I see one or two. Perfect. So you guys know what I mean. You need to really iterate this and continue to improve it over time. All right. So I'm just going to go through this really quick. Business requirements, this is important. Maybe you want to take a picture of this, but yes, you need to align with your, whoever is your manager, your boss, or maybe your investors, and see what is it that you need to achieve, and see what regulations you might have, define data security and all that stuff. And if you have a large corporation, you need to really define different teams that are going to use this model and in which way, okay? So, and especially you need to check with the legal team. It's very important. All right, so I thought about how can we make this presentation a little bit more interactive? I don't want to just talk here and just give you a slide. So I thought about a scenario that recently we worked with, and it actually kind of come across in my personal life. I went to the doctor, and I saw the doctor taking a bunch of notes, and then it's just an infinite amount of notes. There are different patients, there are different doctors that you go to, different specialists and things like that. And I thought about, well, there is a lot of data out there. There is not really much standardization. There is some work being done these days about standardizing how doctors take notes and annotate stuff. But we thought, well, maybe I'll present this work to you guys. So this is more or less a conversation between a doctor and a patient, and there's a bunch of notes with it. And then the next doctor might need to know, the nurse might need to know some standardized notes. So what we decided to do is basically take this and let's make some business requirements out of this, and some objectives, some budget, some timeline, and things like that. So we have 1 week to do this, and so we think that we can improve the way that we give the results to the doctors, and give some sort of standardized way so that it doesn't take that much time for them to pass the information around. So the first step is selecting the base model. So first of all, consider cost, data availability, and business needs, like we said before. There are different types of fine-tuning, so you need to select down. You can do full fine-tuning, you can go parameter-efficient fine-tuning, or you can do some sort of RAG combination, right? And then there are different type of models. There are different models that are open source. There are different models that are more proprietary models, but you still can use it. For instance, like OpenAI, you can use those models through different providers and vendors. So we decided to use 3.5 Turbo. It's super cheap these days. It's about 75. I think the last time I checked, there was 1 million tokens for $0.75 or something like that. It's super cheap. So, and instead of paying so much money for the latest model, we thought, okay, why don't we try this really cheap and expensive model, and then try to fine tune it and see if it does really much better. So what we decided to do is basically, let me go out of here for a second, And then I'm going to start, maybe I can put this here. All right. So let me show you some of the stuff that I'm talking about. So the first thing that we decided to do is basically go and find the raw data. The raw data looks more or less like this, right? And then we decided to take that raw data and then process it. And so you guys can see my screen, right? Yep. Yeah, okay, perfect. So we decided to process that raw data, right? And then we decided to create a script where we're gonna, first of all, we're gonna take the raw data and we're gonna process it so that it can be later on used for fine tuning. So I'm gonna run through some of these steps here really quick. It's some cleanup. I'm gonna start up a tool, a library, which is really cool. It's called weights and biases. And we use it, we love it. I don't know if you guys, have you guys ever heard of weights and biases? Anyone? Yes, perfect. Okay, so we use this tool to do this experiment, and it really helps you sort of keep track of your experiments, track what's happening behind the fine-tuning process, keep all your metrics in place. So, and then after that, what we decided to do is take the data, and then we decided to go on and process it. We created a few functions to go and do the pre-processing. We pointed at that file that you saw initially, and we got some data to work with. So you guys can see here, we got some test data and we got some training data. So we got a ton of interactions, and then we got a bunch of test data so that we can use it for fine-tuning later on. So that's the way we got started. I'm gonna go back here, and you guys can see my screen. Oh, it went away. Okay, perfect. Okay, so we get started. We selected the data. We got the requirements, the business requirements, and then we decided to get to work. So the next step was to prepare. Preparing and securing the training data. That's what I just showed you, and then we went on. Of course, I'm going through this kind of fast. Later on, we can talk a little bit more. But of course, there are some compliance requirements that you need to meet before you just take some data out there, right?
All right. Yeah, just the presentation slide seemed reverted. Oh, if that's okay.
That's
try
right.
to.
Okay. Oh yeah. Let me go back.
Yeah, just for a second. We'll cut that out.
All right. Perfect.
We'll edit that out.
I think there. Okay. Perfect. Okay. Perfect. So I need to do that every time. Okay. Great. Okay. So we selected the data source. Like I said, we got it there, and then now. We're going to do some pre-processing augmentation, which is what I just showed you. We took the data, the raw data, we split it in two parts. We did a little bit of cleaning up, and then we made it ready for experimentation. So, and then after that, we set up a secure and training infrastructure. All right. Anyone works here with maybe Databricks? Anyone here has ever worked with Databricks? Azure? No? Google? Yeah, AWS, any AWS fans here? Okay, perfect, okay, good. So we selected Azure. We work a lot with Microsoft stuff. These are some slides just to give you some, but you have to make it secure. You have to deploy it in such a way that you can control access and things like that, right? That's pretty common sense. And then so we decided to go with a platform which is called AI Foundry. Anyone familiar with AI Foundry here? Yeah, some people, perfect, great. So we like it a lot. It brings a bunch of nice stuff. I'm gonna go out again, and then I'm gonna remember to go back and do it again. But basically, this is AI Foundry. It's a pretty neat platform that allows you to do a bunch of AI stuff, right? I'm just gonna resume it that way. And so what we decided to do is go and create a fine-tune job, basically. And so here you can go and then do a fine-tune model. You can go through the steps here. I'm not going to go through them, and you select the model and select the data that you want to use for tests and for training and for tests, and then you set it up and let it run. So what happens here at the end of the day is that you get here this, for instance, like this. These are the two examples that I run. One I ran, I think, a couple nights ago, and one last night. And then one of them failed, and this is pretty cool about this platform. It failed because it actually detected that some of the data that was used was not failed the safety data check, and that's pretty cool because it already the platform itself, you don't have to do any extra work basically and it detected that there was some data that was not good. It went by us, and so we decided to go back and clean it up a little bit more, and then and we were able to run it the next time. So once you run it, you get something like this, right? So let me show you. So you get something like this. So it shows you the model, you know, how it went and things like that. There's a bunch of logs that you can connect to a platform like weights and biases, and then you can do a bunch of analysis on it. But basically, from here, you can go on and even deploy your model, and so that you make it available for anyone to connect to it and then do whatever it needs to do, right? And so, so going back to the presentation. And then let me remember to do this. Okay, so going back to this part here. Okay, so we decided to use this the infrastructure, and then we did the fine-tune the model like I showed you just now. And then after that, well, we need to evaluate and validate the model, right? Once you do that, I'm going to show you right back. Maybe I shouldn't go in anymore. I'm going to show you here. We went back to we went back to analyze some of the data that we had, and then we went back to really testing the model itself. So what we decided to do is basically take some of the data that we collected before. This is, let me just make sure that I take the right data. This is trained data. We're not going to take this. We're going to take some of the test data, and we're going to use it as actually. Maybe for the sake of time, I'm just going to go back to the playground and show you what was the result. So for instance, here we tested the training data against a regular GPT-3.5 Turbo version, and then we inserted the conversation between the doctor and the patient, and basically we got an output, right? So this is the output that normally ChatGPT 3.5 gives you. You can see here it's pretty GPT-ish, right? Like it gives you something pretty standard. And then we decided to go and check our fine-tune model and see how it did it. So it's basically the same input, but now it gives you a different, without much prompting, without any prompting actually, it gives you a different output, a different schema, and it gives you the information as requested. Of course, across thousands of different inputs and trials, right? So this is, remember, this is data, raw data of conversations, plus annexed with what doctors would have liked to see that like, right? So we created this model, and then, or we fine-tuned this model, and then we reuse it. And then, so this is the result, basically, right? I'm sorry, I'm going a little bit fast, but I just don't want to take much time further. So, and then after that, we did the evaluation of the model. Of course, there's a pretty neat tool that you can use here in this platform, which is weights and biases, that you can actually analyze the data. You can go on and actually create some sort of like a blog or whatever you did. And here are some of the results that you can get out of the actual experiment. You can see here the accuracy, right? If you guys know, accuracy as it goes up is good, it gets better. And there's also a loss as well. This is good as well, as in different experiments, the loss continues to go down over time with each epoch, right? But of course, you don't want to do so many epochs because otherwise it's not gonna go well, right? So you can analyze the data, of course, going back to the presentation. Then you have to evaluate and validate the model. You have to do some statistical experiments on it. And then, of course, you need to deploy the model securely. As we saw it's possible through Azure AI Foundry. But it's possible, of course, with Databricks, with AWS, and we just picked this platform. And then, of course, let me see. I have something. Oh yeah, here are some graphs. You can also compare how well one model did against the other one with this platform. By the way, weights and biases. It's pretty cool. And then we go on to the last part, of course, compliance and document review. That's something that if you work in a large company using a model, you have to do it, and iterate and improve. That's pretty much it. I am at the end of my presentation, but I wanted to leave it up to, I hope I didn't take that much time. I wanted to leave it up for some questions or feedback or comments. Yes? Yes, that's a good question. So it really depends. So if you have really a lot of data that is not available out there, that is not really generalized, then it might be better to just create your own model versus try to make it do something that they really want. But the other option is that maybe you can take a model that is very small and that it does the fundamental stuff, and then after that you can add all the fine-tuning that you need to add. So it's really, I cannot give you an exact answer, but it really depends, right? So do you have a specific scenario that you're thinking about?
No, just orders of magnitude, I guess, and you're looking at something like what you just ran, the experiment you just ran.
Yeah. So for the experiment that I just ran, I think it's much better to just fine-tune. Though there are new techniques, as you guys have seen, DeepSeek, the team come up with new ways of efficiently creating models. So, but if you're running the same experiment for like a company, that has $500 million as an income, it's not going to hurt them to invest, I don't know, $10 million to create their own stuff, and it's going to be super good for them financially.
And for additional questions, please speak and ask questions here. Thank you. Anyone, please.
Great presentation. Thank you.
Yeah.
What's the base model that you use the most, and what's the fine-tuning approach that you use the most? I think there's like Q-LoRa versus full fine-tuning, right?
Yeah.
So.
Yeah, so the base model that we use, because we work with enterprises, they usually like to have their own sort of stuff. They don't like to send stuff to OpenAI. So usually it's Llama. It's pretty popular. And well, the smaller version of Llama, or sometimes Mistral as well. But in terms of the technique, LoRa is probably the middle of the road type of option. Yeah. The 70B is a little bit too big. It depends on the year, but I think it's a 9B version. I think it's the one that we use the most. Yeah. Yeah, LoRa. Yeah. Mm-hmm. Yeah. Yeah.
Hi, thank you for the presentation.
Yeah.
I have a question about the training data. So you have this clinical data, right, of the doctor's notes.
Yeah.
How do you calculate an error for the training, right? Like, what's the metric that you use to train the model that this is a better response or a worse response in that domain specific?
Yeah, actually, well, thank you for asking that, because I can show you something that we put together for that. So we actually defined that as a function, basically. And so we use the same platform, and we created let me see if I can show you. My battery is about to die, I think, but I'm going to show you, hopefully on time. We defined a sort of like a scoring function, right? And so we use the same LLM to compare how the output of, let's say, 3.5, the base model, did it against the fine-tuned model. And so we used it to define that accuracy, basically. It's right here. So yeah, so we decided to set up some sort of like a truth, like a ground truth. And then the generated node will be measured against that ground truth.
Did you start with some clinicians reviewing the data, saying this is a good one, this is a bad one, or?
Oh yeah, of course.
Okay.
Yeah.
So it's a form of labeling.
Exactly. Yes.
Okay.
No, of course. Yeah, that component has to exist. Yeah.
Okay.
Yeah, of course. Yeah. Yep.
Hi.
Hey.
Great talk. I had a question I just wanted to pick your brain on. So there's a lot of libraries that you can use to kind of aid this work. It's a two-parter. Do you have a particular library in mind besides what you were showing us up here? I mean, you're using Foundry, and then you mentioned weights and biases. Do you have anything more specialized?
No, I mean, really all the popular and known suspects of Python. I mean, if you can see here, some of the libraries that I use up here is, just pretty standard. Yeah, I don't know, OpenAI, Pandas, Weave. Yes, it's not really it's really about the use case that you have. You will need some specialized libraries, for instance, for fine-tuning vision models, like we did that, and that was quite fun to do.
Like deep stream?
Yeah, exactly, yeah. So that's kind of more specialized, but stuff that we're doing here, for instance, is pretty straightforward.
Have you ever thought about using some of the larger models for chain of thought? Or I heard somebody talking about LoRa. What are your thoughts on those?
Yeah. So we try to stay away from really large models and fine-tuning really large models because it sort of defeats the purpose, right? Because you have this gigantic ship that you want to steer it just a little bit. So it doesn't make that much sense to do that with that, but instead just taking a smaller ship so that you can steer it better, right? So, but we have tried it, and it costs a lot of money.
Yes, it does.
And yeah, I mean, just to do this, it took like 5 hours of intense GPUs, So it was quite a feat given the project. And this is just a really POC version of the real project,
Just one last follow-up. How do you identify the right base model to use based on the domain you're solving for, the problem you're solving for?
So that's actually a talk on its own, but really has to do with your budget. It has to do with all the data that you might have. It has to do with all that. But it depends, right? Like there are some models that are really good at coding, or maybe for workflows. Like Mistral is pretty good at workflows, for instance. There is Llama, which is really good at sort of conversational stuff. It really depends. I hate to not give you an exact answer, but
that's okay. We could go on about it.
Maybe one day we'll do that, Grant, and we'll do a talk just about like selecting the right models for the right tasks. Yeah, that'll be really cool to do. Yeah.
Thank you.
Yep.
Thank you for the talk. I think it was great, especially the demo and everything. I think it was really useful.
Yep.
My question was regarding the deployment of the model. You showed that you deploy the model in Azure. Does that give you an API, or is that something that is like a jar file or like a pip file that then you download and then you open an API into it? Or
let me show you. Maybe I can show you.
How easy is it for someone else to start using that?
Yes. So let me show you. Here are the models, and then of course with each model you get an endpoint. You see here there are different endpoints, and there's the keys and things like that. So you can actually consume the model deployed immediately. So yeah, it gives you an endpoint, it gives you security, it gives you scalability as well. And you can even deploy this as a chat immediately, as a chat app, basically.
Oh, that's amazing. And I'm guessing there's like a Google Cloud equivalent to like the Foundry.
Yes. Google also has its own version. And also AWS, it has SageMaker. Well, everyone has its own tools, basically. But we really like Azure. But I'm a little bit biased. I used to work for Microsoft for a number of years.
Oh, there you
go. I'm a little bit biased.
Okay.
Though I love other stuff too. I love to try new stuff. Yeah.
Amazing. Thank you.
Yeah, of course. Yeah.
Hi. First of all, nice to meet you.
Hey.
And thanks for the presentation. I'm not the most technical person, and I still understood most of what you said, so it was great.
Good.
And then my question was, as not being the most technical person, could you speak just a little more on like DeepSeek and how they have been developing it and how that kind of happened to now compete so quickly with OpenAI? And I guess in general, what do you think is the future in that? If you believe OpenAI is going to continue kind of being on top, or if you think DeepSeek, or if you think something completely different is going to be kind of on the forefront of everything? Yeah.
Well, that's also another topic for like a full conversation, but I'll give you a 1-minute answer on my perspective, right? So yeah, they demonstrated how just using innovative techniques that are not really new techniques, but are different ways of arranging the cards, it's possible to be way more efficient, right? And so I think there's going to continue to be more and more models like that. And we're all going to continue to enjoy that, right? Because it's getting cheaper and cheaper. It's getting commoditized, basically, right? So what is going to be the future of that? I think we're going to have cheaper and better models, the next few years. And yeah, it's going to be good. But like I said, this is a very long conversation, and I would love to maybe chat after and maybe talk a little bit more about it. But it's a fun topic. I love it.
Yeah, cool. Yeah. Let's do it. Thank you.
Yeah, of course.
Hey, how are you?
Hey.
Thanks so much for the presentation. It was very interesting. I had a question on the data collection and reprocessing part when you're using the kind of training data for fine-tuning the model. I know you flashed up a little bit in terms of the accuracy scoring from the question that came earlier. I also wanted to know a little bit better about your kind of methodology, but behind collecting and gathering. I'm sure it differs use case, but maybe more specifically in the use case you were highlighting here, you were gathering then the large amounts of kind of doctor annotations that already existed, and then you would create ideal versions essentially of them or correct them and vet out like, hey, these like 100 versions, here's the better version of them, for example.
Yeah. So if I understood correctly, you're saying, well, how do you go about assembling the right test data so that you can verify that whether it's good or bad, whatever you're getting in the output,
Yeah,
right?
the data that you're training it on, yeah.
Yeah. So actually, fortunately we had the input of, like I said, physicians that went on to actually label and see a ton of examples and say, hey, this is the way we would like. And of course, there has to be some sort of standard on what was the answer. So we established some sort of a standard, and we said, given these notes that you see here, what do you think would be the best standard? And of course, we helped a little bit the physicians with some automation behind the scenes, and we say, this is what ChatGPT more or less looks like. We did some prompt engineering behind it, right? There was a bunch of prompt engineering to kind of get to a standard, and then based on that, we kind of gave the physicians, hey, how does this look? How does this look? How does this look? So the physicians didn't have to actually write it, but they kind of labeled. They did basically reinforcement learning on it, right?
Yeah.
So that's sort of like the approach.
Just to make sure I understood correctly, so let's say you have 100 of these annotations, you then create a standard schema that you want to kind of follow and break out into.
Exactly.
And then you would translate those 100s into what would be like those 100 different annotations into what would fit that schema and say, okay,
Yeah.
this was the raw data,
Yeah.
pre-trained, this
Yeah.
is what following this schema would be the ideal output of it. And then
Exactly.
you have and also in terms of how thorough and how many records of that, what do you typically follow? I guess it also probably differs use case to use case.
Yeah, but for instance, on this, I think it was something like 200. I think it was 200.
200 records?
Yeah, 200
Okay.
that we use. But of course, this is like a POC version, right?
Yeah, sure.
But you probably have, I think the real project was around 2,000 or 2,500, something like that. Yeah.
Interesting.
Yeah, because it's also chat completion.
Yeah.
You shouldn't really need that much because GPT 3.5 is actually pretty decent at it. And if you give it a sort of standard, then it's going to follow it pretty well.
Okay. Sounds good. Thank you so much. Appreciate it.
Yeah, of course. Thank you for your question. And before anything, I just wanted to thank Grant for putting this together and for doing all this. It's really cool that you do this. This is super important. What you're doing is really important for Miami, for the community, and I really thank you for that.
Thank you.
Yeah, of course.
Everyone knows it can't be done without the community and great people like yourself.
Yeah, of course.
Thank you, everybody. Thank you.
Yeah. So you had the patient notes, and then in the patient notes it was like doctor, patient, right?
Yeah, exactly.
And then you converted that to the chat ML format. That's what you did?
And then you convert that into what would be no, you don't convert that. You have to clean it up, of course, and make sure that you get rid of, clean it up. And then you pair that to what would be the ideal output or the standardized output for that. And then you have a ton of those, and then you use that for training, basically.
So it's like, I mean, when you do the messages with ChatGPT, it's like user or assistant, right?
Yeah.
That's the chat ML format, right?
Right.
So you made the doctor the assistant, and then you made the patient the user. Is that what you did?
Well, we basically fed the whole conversation, basically, to ChatGPT or to the GPT model. And we fed it, and we say, hey, given this conversation, what would be the notes that you would draw for this, right? Because we're talking about full conversations. Yeah. It's not just the individual interactions, it's full conversation.
And then when you're doing the fine tuning, what's the prediction that then gets adjusted? So is it like you'll omit the last token of a particular conversation and then have it guess the last token and then you'll adjust the weights based on that, or how does that work?
What you predict or you're trying to get to is an output. What would be the output given that conversation? What would be the ideal output as a notation, basically, the annotation output for that conversation? Give it all the information and interactions that you have. What would be the ideal output for that?
So you're doing the difference against the overall output, not just one token at a time?
Right, the whole output would be. Yeah.
And how does that work where you calculate? I guess you go token by token, measuring the difference, and then you adjust the weights based on that? Like, how does that work?
No, you may, so remember the function that I showed before, the sort of measuring function? What it does is it takes the two outputs, one from the base model, the other one from the fine-tuned model. It takes them, and actually we use the same AI to measure that, and we say, which one do you think looks better or not? And then, or we use it to sort of measure against each other, basically. Right?
So you use another AI to look at the two outputs and then
Exactly.
give you a score of how
Exactly.
similar they are?
Yeah.
And then you try to adjust the weights
Yeah.
to reduce that.
Exactly, yeah. And we also use human input to say if whether it was good or bad, or this also, I didn't show that, but this also has some human in the loop.
Use the same model that you're fine-tuning for doing the judging, or?
Oh, we have to change the weights and things like that. We have to continue to improve it over time, given the feedback that you get.
Okay.
Yeah. Maybe we can talk a little bit more about
Yeah.
I can. Yeah. Yeah, of course.
Dustin, thanks for the talk. You spoke about a spectrum of prompt engineering to retrieval augmented generation, to fine-tuning, to pre-training. Could you speak about the middle two? Like, could you have used retrieval augmented generation? What would you have lost if you'd taken those doctorate notes and just used that technique? Like, what's the metric of when you want to go towards fine-tuning?
Yeah, so we could have done this with RAG, but then in that case you would have to ensure, like somehow you have to ensure, because let's imagine, like if we did this with a RAG, you guys can imagine that the instructions or the template would have to be either in a prompt or in a document somewhere, right? So you're going to have to trust the model to take that and then effectively do it the way you want it to do it. That's one thing. And then we have seen that, for instance, for 4.40, it's about to die. For 4.0, before this dies, I want to answer your question in a second. I wanted to say this before this goes away. There's this, we do this every time we talk in events like this, and we give the opportunity to startups mostly to approach us, and we give you guys a hand to build a POC for whatever you're working on, right? We won't select everyone, of course, because we also have to make money, but we will help you get there to the three of you, like 3 startups get the opportunity you get some consulting hours, and we help you set up, at least we get you halfway there so that you can do your AI project reality. You can come to your AI project reality. So you can scan this, and then there is also my LinkedIn, I think a link to that QR code, hopefully we did it right. And then you can add me if you want to in LinkedIn. You can, we can chat later. And then, yeah, there is a form as well where you chat a little bit about your startup and what it's doing and how can we help you, okay? And now I go back to it before my screen dies here. But yeah, so we could have done this with RAG, but then you have to make sure that the model is going to follow what you need it to do. And you can do very well that with models like 4.0 and ahead, but that's a little bit more expensive, right? So it comes down to cost. And then with 3.5, then you can do it reliably, as we saw, and you can pay less. But the other thing is also the tokens that you use just like out of the bag, because with RAG you're going to use more tokens instead of having everything already in the model.
So it's cheaper, more efficient, going for the smaller model with fine-tuning as opposed to a RAG on a larger model. But you might get similar results.
Yes. The other thing is that you avoid, sometimes users might override you with a RAG, right? There are different ways of override your instructions, your base instructions. So with a fine-tuned model, you don't get that usually. There are techniques to do it, but it's really hard to do it for a regular user.
Thank you.
Yeah.
And one last question.
All
last but
right,
not
perfect.
least.
Yeah, let's do it. I'm trying to get to them pretty fast. I want to let you guys go.
Thank you. I wanted to ask a little bit more about the human in the loop part. Is it like prompting one answer or the other one is better, or what exactly does it? What exactly are the inputs after the human in the loop, and how many iterations do they have to go over? How many samples or whatever?
Yeah, of course. So there is a technique to do it through prompting. Basically, we do is basically what ChatGPT does these days, right? They show you two different outputs, and you select one or the other. So that's actually pretty fast and pretty popular. The other technique some people do as well, we like to do it sometimes depending on the scenario, is to actually have the human review it and give you a score, right? We do scores. So you can do either both of them, but they both work. Oh, how many? In this case, I think there was 2,500 reviews, right? And so I think 80% of them were reviewed, or something like that. Yeah, but you don't really need that much with chat completion. Like I said, it's pretty straightforward. Yeah. Thank you so much.
Amazing. Thank you so much,
Yeah,
Dustin.
yeah, of course.